Hello, I'm Steve Larson, engineer with Cat Pumps. Today we're going to talk about feed tanks. A lot of high pressure pump applications will require a feed tank. And today we're going to talk about the things to consider when designing and installing a feed tank. So first of all, we're going to draw a nice rectangle feed tank. And we're going to connect to it a inlet line that goes to our pump. Now with any system, this water has to go somewhere afterwards, so we're going to just, for this example, put in a little regulator here, trigger gun, spray nozzle, and of course the regulator will have a bypass line coming out of it. So we have to route this line back to the tank. So do I want to put it here? And the answer would be no, because I'm going to get a lot of water coming back here, and this is my line going from the tank to the pump, and what I want to avoid is any turbulence and water eddies and air entrainment or everything like that that can get drawn into the pump and cause problems. So I'm not going to run my bypass line there. I'm going to actually take the bypass line and run it over to the other side of the tank up near the top. And of course I do have a level of water in here, and I got to repair this little hole I made so that it holds water. And so now I have my inlet line to the pump and the bypass line coming back to the tank here, and this is my water level, so everything is good. Now the other thing that happens is when the pump is operating, it's going to draw water out of the tank as you spray out the spray nozzle. So as we're sending water out the nozzle, the tank's going to start to come down, so we've got to fill the tank at the same time. So on the same side as the bypass line, I'm going to come in here with a source of water, and what we want here is we want clean and filtered. The reason we want this clean and filtered is if I don't clean and filter it at this stage, I'm going to have to do it at this stage, which is my inlet line. And I don't have a lot of inlet pressure because of the vertical distance of the water here. I don't want to put any restrictions in the inlet line that are unnecessary. And putting a filter in there that can clog and restrict my inlet flow is detrimental. So I'm going to clean it and filter it before I drop it into the tank. Now a lot of city codes will require an air gap here so that the water comes out of the piping, goes through a little bit of the air and into the tank. That way there's no chance for this water to go back into the city water system. So there's an air gap there. Well, when you have an air gap and you're shooting water in here, it's going to create bubbles and things like that that shoot down into the water for a while. And we want to make sure the tank is large enough so these bubbles don't migrate over and get drawn up into the pump. So the first thing we can do is we can add a baffle right here on this side of the tank. And I'm going to put it above the water level, but not quite to the bottom of the tank, because I want the water from this section to flow under that baffle. That way these air bubbles are trapped in this portion of the tank and they can be dissipated out. Now, there's particles and things that can still possibly be in the water that I don't want to get to the end of the pump. So I'm going to add a second baffle here. So then in this area here, we have where the particles will settle out into this portion of the tank. That way as the water flows in through here, the bypass line as well, comes through here, under here, up and over, that this area of the tank is a nice, still, like a pool of water undisturbed, so that as the water is drawn out for the pump, it's nice and smooth, there's no turbulence. Now, another thing to watch for is if the baffle is too close to here, and I'm going to put this in red, because if the baffle's too high, then I have a high flow of water coming across here. As this is drawn down and it starts to spill over, and it can create an effect like water over a dam at the bottom. It's very, very turbulent. So we want to avoid that. We want to have it a nice flow of the water, just enough so that we don't get the particles coming up and over that baffle. And that's a good inlet arrangement for a tank design. The other thing we want to do is, last thing we want to do is right here, we want to add a level indicator or a switch. Something that will warn us if the water starts to get too low, that we don't want to empty this pocket and starve the pump, run it without water, because that would not be good for the pump. So these couple of simple basic things to watch for when tank design is that, and the last thing to cover is the size of the tank. Let's say this is a 10-gallon minute pump. Then we want a 60 to 100-gallon tank, 6 to 10 times the capacity of the pump. The pump is 10 gallons a minute, we want a 60 to 100-gallon tank. That will ensure us that we have a nice, slow-moving water through this tank. If it takes 6 to 10 minutes to move from one end of the tank to the other, that's very slow-moving. A good time for the air bubbles to dissipate out, the particles to settle, and continue to have good, clean water for your pump system here. And those are the basics of good tank design.